Hello viewers, let's look at radius and center of curvature. We are trying to demonstrate by using this diagram. You can have a curve like this where we can mark 2 points Q and P, and we locate the center, and also you use this as radius. This can be used as change in theta, and also this is change in length of an arc. Now from this diagram we can actually deduce some things. First and foremost, we are saying that change in length of an arc is the same thing as radius multiplied with change in angle. We can call this equation 1. So we can actually shift this part of the diagram and we present it this way, and we can call this change in the vertical axis. We look at this change in the horizontal axis, whereas this can be used as change in the length of an arc. So at this point, when we look at this, we realize that tan theta is actually change divided by change in x. Now, if change in arc is close to 0, so we are saying that tan theta is change in this divided by this. We can call that our equation 2. And also from this same diagram we have that cos theta is equals to change in x divided by change in s. So this can also be written as cos theta change divided by x. So we are calling this equation equation 3. So we are going to use the 3 equations to actually develop the relationship that exists between the point and the radius of curvature. So at this point we can write this out, that dy dx is equals to tan x, and we can actually write this like this, that is change in length of an arc on both sides. So we realize that there is no component of s here and there is no component of s here. Rather we are having x and tan and theta. So at this point we can actually write this like change in x into dy dx and change in x divided by this. So if you look at this and this, we can, it's the same thing because the x can actually cancel out. And similarly we have change in theta into this, we have the theta divided by the x. So at this point we can actually carry out the equation. So what are we trying to do? We are trying to recall that 1 over 8 from equation 1, 1 over r is equals to change in theta divided by change in x. So that is from equation 1. That is from equation 1. Let's write this out. from equation 1. So at this point, we can look at this, and look at this, and also look at the x, the this. Look at this. So all this, you have to substitute them to actually arrive at what you want. So at this point, we write this out. This, the s is cos theta equals to change in this tan is sec square theta, and the theta, the s, actually, we have it to be the theta, the s is this. So we can replace the theta, the s with 1 over r. So at this point, we can divide through by cos theta. So we have that this equals to sec divided by cos theta multiplied by 1 over r. So this is giving us that this is equals to 1 over cos theta is sec. So this is actually 3 because of 1 over cos. Multiply this with 1 over this. So we actually want to deal with sec cube, and this we can write it this way, that this can be written as squared into 3 over this, and this can eliminate this. This can eliminate this, and we multiply with 1 over r. So we can also replace that with 1 plus tan squared this into 3 over 2, and that is multiplied by 1 over the radius. So in this, we are saying that radius of curvature is the same thing as 1 plus tan squared 3 over 2 divided by the second derivative of that function. Now, but we can replace tan squared with equation with this, with equation 2. That says that radius is equal to 1 plus dx squared into 3 over 2 divided by the second derivative of that equation. So knowing this expression will give you the idea of the radius of a curvature. So let's look at center of curvature and see what we are going to derive from it. Center of curvature is actually going to be this way. We can look at this same diagram where we can pick a point. We can pick a point, and we can pick a point in the same diagram. We can do this. We can pick a point and call that x1 and x2, and also we can call this point h and k. So we are looking at what will be the center of curvature, whereas this guy is still the radius. We can construct a triangle like this. Triangle. So this is your H. And also, whereas this is your K. At this point, a point is given, and this is your Y1. Whereas a point is also given, and that is your X1. So at this point, we can write this that between this place and this place, we can call it sine theta. And also this place and this place, we can call it r cos theta. So to actually look for the k, it will become, k is going to be plus r of this, and h is going to be, we know this x1 minus this. So that is what we are actually looking at, this sine this. So we are actually concluded that in curvature, the radius is equals to 1 plus dy dx, you square it into 3 divided by 2 divided by this and this, and the center becomes this into y plus this cos. So that is the radius, and that is the as a radius, and that's the center of curvature. So we can actually use this example to look for the center. We can use this example to look for, to have this. So we are saying now, example, find the radius of curvature and the coordinates of the center of curvature of a curve. This is the expression at point 2 and 2. So that is what we are going to deal with, and we start by writing out what was given. So we have that y is this divided by this, and the point that is given is this and this. So at this point, we write the formula for radius of curvature, and it's 1 plus dy dx into 3 and this. So at this point, we can solve this by looking at the parameters that's involved in the radius of curvature. Now, we need dy dx of the expression, and this is a quotient rule, so we can actually do this differentiate the x, which is 1, minus x, and differentiate this minus 1, and you actually divide by the denominator, and that. So trying to simplify the equation, we have this minus x and we have this plus x, this and this. So the answer is 3 this minus x divided by 2. So but at point 22 we have that the y dx at point 22 is actually 3 divided by 3 minus 2 squared. The answer is 3. That is the y dx value at that point is 3. We also have to go over it again, and we are having that the y dx is 3 divided by this, and this the second order is the same procedure. So we are going to divide that. So this is giving us the y dx is 3 minus this. Differentiating 3, we have 0 minus 3. Differentiating this, we have 2 into minus 1, 3 minus x, 2 minus this, divided by 3 minus this into 4. So let's try and simplify what we've got. We have that the y dx is actually, this is out, is 0. So we have this, which is 6. This is 6. This time this is 6 into 3 and 4 divided by this raised to the power of 4. So we can actually simplify further by saying this divided by this x raised to the power of 3. So at this point, let's clear this off. Let's clear that off, and at point 22 we are having that that will be 6 into 3 minus 2 is power of 3. The answer is 6. So we have all the components that give us a radius of that curvature. So we are saying that r is going to be 1 into, and we have 3 to be our divided x, so 3 into this, and also we have 6 to be the second order, which is this. So we can actually make this 10 into this divided by 6. So the x at this point is 10. The x at this point is square root of 1000 divided by 6. Square root of 1000 divided by 6. So similarly, we are going to the center of curvature, that is h and k. H and k. This is this minus, and also this is this minus cos this. And we are actually looking at what is theta. So we I've established that the theta is the same thing as the x, and that is tan theta equals to 3. So the theta is arctan of 3, and from here we will actually find out the relationship and the value of the theta. We are still on that. The radius is actually root of 1000 divided by 6, and we have 5.27, and x1 was given, that is 2, y1 was given, that is 2. So now we are looking at finding the theta, the value of the theta, and we've said that tan theta is the same thing as dy dx, and dy dx in this example is 3. So we've gotten that theta is arctan of 3, which is 71.6. So when we substitute 2 here, 5, 71.6, we have in the vertical axis that the center is 3.7. We also do the same in the horizontal axis, we have that. So at this point, we conclude that this is the center of curvature and this is the radius. Thank you very much for listening.